All right, hi, my name's Calvin Woods. I will be going over Yerkes-Dodson Law with you. To define Yerkes-Dodson Law, it's that Yerkes-Dodson Law is a correlation between performance and arousal. So the point of Yerkes-Dodson Law is to find where the optimal outcome lies based on the given task. Now, I want you to know that it is important to note that there is no scale that represents the optimal point or outcome for everyone or any task. Everyone's optimal outcome differs. So let's look at this graph for a second, because we see that performance is typically on the y-axis and that arousal is on the x-axis, and that there is this peak where that's where we're going to get this peak performance or this optimal performance, and that's where we have optimal and optimal arousal and optimal performance meeting. Going into the history of Yerkes-Dodson Law, and Cherry in her article, and especially if you just read her abstract, does a great job of explaining it. But basically, Yerkes and Dodson put rats in a maze and made the rats navigate their way to get out of the maze. They would send electric shocks to the rats, or to the mice, and the mice either reduced the number of trials it took to navigate their way through the maze, or actually had more trials to get out of the maze. And one of the things Cherry does a great job of showing us is that with too little of the shock intensity on the mice, or too much, that the rats weren't even close to this optimal performance as when they had the right optimal arousal, which that means the right shock intensity. So I want you to look at this graph for a second, because that graph is what we're going to use on the next slide, and that's this graph on the right. And basically, this is what it was thought of between 1908 and 1957, and that is where, with a difficult task, which could be like a multitasking task or a decision-making task, is that there is a peak between optimal arousal and optimal performance, and that gives optimal outcome. Now, what it was thought of was that with a simple task, which could be a flashbulb memory, is that with optimal arousal, once that optimal arousal was met, the optimal performance actually stayed no matter how much more arousal you put into it, which means you could put a ton of stress into a simple task, but once that performance is reached high, it just stayed there. Now, let's look at the graph on the left, because now it's thought today and after 1957 that when optimal arousal and optimal performance are met, the optimal outcome peaks. Remind you, there's variability based on persons and based on the task, which could be easy task or difficult task. So what you've been seeing is the inverted U model, and what our book shows is that by Schmidt and Lee, that the inverted U principle suggests that there's no simple relation between the level of stress and the quality of performance. So what the inverted U model does, it contradicts this theory that in human performance you have to have a high amount of arousal to have strong performance. The U model actually has explanatory power and scientific evidence that there is this relationship between arousal and performance, that they will meet at this peak point, and that it's more complex than having to have high amounts of arousal. So the important part to remember from Yerkes-Dodson Law when we're talking about motor behavior is this idea of attention. You can go to lecture 11 in module 1 and really look into this, because it really connects a lot. And basically, it's Yerkes-Dodson Law applies to motor behavior through attention by connecting human performance with arousal, and it connects us to the ideas about attention. So in motor behavior, Yerkes-Dodson Law helps us characterize this relationship with arousal and human performance, while being able to back supporting evidence to when optimal performance is reached or where it could be reached. And remember, there's variability based on the task and the person. So I'm going to bring you to this third article I have in this presentation. That's with Anderson. Basically, it was a fascinating study where they gave these subjects caffeine, and with a certain amount of caffeine, which it was actually a lot, performance on easy tasks tend to improve, where on difficult tasks, and it says impulsive and non-impulsive subjects, but performance deteriorated. So my question for you is, why would the optimal performance or the optimal point be lower on average for more difficult or complex tasks as compared to the optimal point being higher for the tasks requiring endurance and persistence?